Bonjour mes amis et bienvenue à .NET API Review. And something about being 10 a.m. in Redmond, but words are hard. Uh, yeah, so we still have a whole bunch of things on the agenda, including what looks like Tanner wants like 8 more months of review on ARM64 stuff. But today we're not talking about any of those. Not, I mean, we're talking about things on the list, but we're not talking about the ARM stuff. First up is add managed API surface area for ByRef-like generic constraints, 68002.
Okay, so this is expanding an existing type in enum to set a flag. These flags are baked in metadata. So you can, the generic parameter attributes, these have things like variance, covariance. I think they have the class constraint on there and a few other little
Yeah,
things.
contravariant, covariant, default constructor, not nullable, reference type constraint.
All
Right.
those.
Yeah. And mask.
Other than the variance constraints, there's there's a everything else is considered a special constraint. That's where that mask comes in. I can get to that later, but this is purely saying this is for a Roslyn feature that has been committed to the best of my knowledge. I don't think anybody from Roslyn's here, but I'm sure Steve can talk about that a little bit. He's probably in those meetings. This is permitting generic. This is permitting the use of ByRef-like types as a generic parameter.
So I can do a func of span of byte.
Yes. Yep. Exactly.
Yeah.
And on that note, there will be follow-up. We'll either need to review or sort of just give a blanket pass of places that we want to apply the relevant constraint to existing types. In particular, what you just mentioned, Emo, like delegates, we're going to want to annotate pretty much all of our func and action types and probably some of the core interface types.
And the reason this annotation exists is because it's still not valid in all cases, right? You can't do a list of span of byte because, well, you still can't create arrays with those.
Right. So it's sort of an anti-constraint in that it's about limiting what the method is able to do. And so the method basically signs up to say, if you have a T where it's allowed to be a ref struct, the method is then signing up to say, I will never store this on the heap in any way, shape, or form. Right. And so it can only be applied in cases where it can make that guarantee.
So does this basically mean there's a new flag in metadata as well?
Yeah, this is the flag.
This is the flag.
This is the flag, yes. Now they've called them, as Steve just mentioned, anti-constraints. It kind of you could interpret it kind of one of two ways. You're constraining what can go on in the method, but you're also at the same time expanding the type universe if those two things align. So depending on which way you want to look at it, it could be a constraint, could be an anti-constraint.
And are we sharing this type of system reflection metadata? Because that's actually what I would expect it to see.
Yes.
So we share this?
This is the same type to the best of my knowledge. Maybe I missed that.
Because in many cases we don't share types, that's why I'm asking a lot of this stuff.
Well, I believe this enum is used in reflection of that.
Yeah, no, I mean, I'm saying there's system reflection and reflection emit, and then there's this other thing that we also call reflection, but the system reflection metadata, which is the low-level IL parser that is then used by Roslyn to crack open metadata, right? Because they don't go via reflection. They build their own object model over.
I see.
And that's why I'm thinking I was more expecting it to see it there. I mean, it probably also wanted to expose it in reflection emit as well, but
there's another enum, but yeah, if there's something else I need to update, let me know.
Yeah, I mean,
that's kind of
assuming the names are the same, this is the only hit on it. Like, reference type constraint is one of the names out of this enum.
Yeah, no, you're asking hard questions. Yeah, the type of share. It's
The few
on,
places I looked, this was the one they
it's
were
in
using.
system reflection metadata. There's a type called generic parameter that has a property attributes which links to the same type. So yeah, that makes sense.
Okay.
All right, so that makes sense.
So just to be clear, this has, so I filed this 2 years ago, almost 2 years ago. There is basic support. There's been basic support in the runtime for this for a while. So it's been in there. No way to get at it other than through IL. So I believe Rosalind right now, I know Jared had asked, can they use this and play with stuff? Like, yeah, sure. So they're setting the bit that they need to set, and I'm assuming they're playing with it. I have some follow-up work that I've done to address some other features that have come through and fix that up. But I believe at present this is the last thing that's needed to expose it from a public surface area.
And that's different from the other ones, right? I mean, contravariant and covariant are kind of not constraints. The other ones are constraints, and this one is more the other way, right? It's the I allow additional stuff, right?
Yeah.
Well, again, for a delegate, it's I allow additional stuff. If you're a generic method or a generic type, then you're saying I promise I'll behave with these other things. So
we actually need.
Go, Tanner.
Go ahead.
I was gonna. So it's a expansion on delegate, and it's a limitation on types and methods.
It's an expansion on what the generic can accept.
Yeah.
But it's a restriction on what the method can do.
Yeah.
Or the type for that matter.
Yeah,
right?
nothing to do with generics or nothing to do with delegates specifically. It's depending on where the implementation has to be restrained, the type universe can be expanded.
I mean, you can use it on classes. It just means you can't do anything, like creating an array of that type T, right?
The language isn't going like span of T. If we say that T can accept a biref, like it's not going to fail to bind the delegate to a method whose signature takes a classic reference type and stores it. Right? Like
no, I think the language will enforce that, right? So if you have a regular method like today without this constraint or without this modifier, you can't pass in a biref type. So if you add the modifier to your T, where you say where T : whatever the language syntax for this ends up being, then you can, but then the compiler will ensure that you don't do anything that's disallowed with those things, right?
Right, but if you have an existing thing that is being targeted by a span of foo, if we add this attribute on, and I mean this is really the discussion for the follow-up when we start painting this in places, it shouldn't say, hey, this is no longer able to be a span of foo because you saved the T. You didn't act on it in a biref manner. Because you're now a specific foo, you're not a biref type, so you're allowed to save it. But I think you'll still be allowed to be a span.
I'm not sure I understand the question.
It's whether or not when a specific method gets bound to a delegate instance, I don't think it's going to care what the body of the method does. It's only going to care about could the type be applied.
It'll care whether the method is constrained according to the same constraint that's on the delegate. Yeah. So in order,
if it's generic,
yeah.
If it's specific, you want a span of foo, and you have a thing that takes. Sorry, you want a func of foo, and you have a specific thing that matches that. I take a foo, then like that'll bind even if you did weird things, like save it. Anyway, I think the answer is yes. We're not making a massive breaking change once we start painting ref on span, not span.
So
func.
I did validate this is the implementation is a non-binary breaking change.
Yeah.
Okay.
In all cases.
So I think what you're asking, I'm not entirely sure what you're asking, but I think what you're asking is if we change func of T or action of T to include this modifier, is that a breaking change? The answer is no, because you widen the types you accept.
Right, and
the consumer. A consumer isn't broken by that because similar to how we did this for event handler of T at some point, where we removed the constraint that T has to be derived from T args. I think you just widen, but I mean normal consumers or existing consumers, in order to instantiate the delegate, would have to have the same constraints. So they're as limited as the current types are. So unless they update themselves, you still can't use more of it.
That's right.
And
And I think the
budget that.
primary impact on us will be when we choose where to put that. When we choose where to put this, there will be additional things we'll need to factor in. So like when we put this on an interface.
The check the Teams is down.
Sorry. When we put this on an interface, that will effectively
password right up there.
prevent us from adding DIMMs to that interface in the future.
So a question I have is, do we actually have to obsolete special constraint mask? Because except by ref like isn't a constraint, it's an anti-constraint, and that's explicit in how Roslyn and the runtime have so far discussed and thought about it. So special constraint still is applicable because it represents the entire set of constraints you can apply to a generic parameter. And except by ref like is a new thing, which is an anti-constraint, which expands the set.
Well, I guess what all values are currently painted by 1C?
We're back.
Sorry about that.
We lost internet here.
Well, we could hear you the whole time.
Oh, great. That was funny.
So 1C
Is
does,
these three things.
Yeah, it's all the special constraints that currently exist. I wanted to change it, but then I recall we can't do that because enum values are embedded. Changing an enum value is a binary breaking change.
It's not binary breaking, it's potentially source breaking, but the thing it's embedded just like a literal constant is. So if you change it from version 1 to version 2, then when they recompile they get the new version, but they silently get it and they don't know. But my question was, do we need to obsolete it because byref like isn't a constraint, it's an anti-constraint, and that's very much how the language and runtime have discussed and referred to it, because it's expanding the set of allowed types. And so special constraint mask still represents the entire universe of constraints you can apply, and the thing we're adding is a new concept, which is an anti-constraint, and therefore it is a different mask logically.
So that's a fair question. I guess I don't have any strong opinion one way or the other. I honestly don't think that mask matters, to be quite frank. I found like 3 places in it in the runtime, and it was all used in weird ways and no real value. I could easily remove them. I don't know if that mask actually has value, because they are just bit fields, bit flags. So I don't know why the mask is even there.
Yeah, it looks like there's across all of GitHub maybe 81 usages of it.
But
and several of those are copies of our own code.
Yeah.
I don't know why anybody would use it. The places that we used it, we masked off we masked just the constraints, and then we just checked the bit. It's like, you're not doing anything with this mask. It doesn't solve anything.
And then the new one is outside of that range. Is that
yeah.
Right. Well, because it's defined as only the 3 specific bits, and then because it looks like somebody just wanted to be helpful for if you wanted to take the constraints and be like variance : and then like thingy and variance mask, and then it'd say none, and then special constraints none.
There's a reason why we have these rules not to do that.
Well, this API's.
No, this is
since the beginning, I'm sure.
This is with the API. You're sure that.
Yeah, this is purely a projection of the native side. So it's been there since forever.
Can anybody see Jeremy's screen, because all I see is an icon?
I can see .NET API catalog.
That's what I have on screen.
I'll be back 1 second.
Yeah, so for the language thing, Steve, both of these will still be valid after action of T gets painted, right?
Yes.
And this won't, because this would be just like anywhere else where you're now more constrained, and so now just what your T's are allowed to be is limited, and then this will also still bind.
Right,
You stored it, you violated the ref
violated the ref
semantics,
semantics.
but this bound.
Yes, that's fine.
Okay.
It didn't violate the ref semantics. Its action is allowed to be constructed with something that is a ref struct, and it's also allowed to be constructed with something that's not a ref struct.
Yeah.
Yeah. I was just, when we were saying, so in this function here, the T couldn't be saved, because it would say that if this is actually a ref type, it would break the world. But
right,
the body
example,
here wasn't constrained.
If I had an action of span, I wouldn't be able to bind that to alpha because I can't construct alpha with a T equals span.
Right.
But I would be able to bind it to beta.
Okay.
And the safe to escape span rules ensure that the default safe to escape rules for span ensure that it remains consistent.
Okay.
And then the other thing to note is the syntax will be more like where T : allows ref struct, because where T : ref is a constraint and is theoretically different if the language ever added that in the future.
There. And
Yeah, they haven't decided on the language.
Right.
But I'm pretty sure it will not be canref.
That we agree.
Sure.
That we agree.
But the okay, so I was just making, because there was a statement that that this bit was going to say that ref like preservation rules needed to be enforced, and I was making sure that was only in bodies and not in delegate binding, because if it was in delegate binding, then we were going to have a lot of trouble.
Well, it affects delegate binding when there is a concrete type specified for the generic. Like, so if it was action read-only span, then that can't bind to something that can't work with read-only span.
Fair enough. Okay. All right, are you back online, Emo?
Sort of. I mean, we dropped out once more, so we'll see.
All right, so the question that we're really discussing right now is the obsolete warranted? I mean,
it depends on our definition of what special constraints was supposed to be used for, right? So if somebody's using it currently to just mark all these three things, well, that behavior is the same. If they made an assumption that they get everything but covariant and contravariant, then that's going to be no longer the case, right?
Well, then they should use and tilde variance.
Sure, like
write the code for what you want.
This exists since 2005,
yeah,
so.
Yeah.
I mean, the usage is probably going to be very low, so it probably doesn't matter one way or the other.
Yeah, I don't think it's going to be high usage, and I think given the way that the language and runtime are referring to this, because it's an expansion of types, there's effectively this implicit constraint that already exists that you can't mask out. And so the new thing is a special anti-constraint.
Just to be clear, the runtime isn't referring to it. It's just a constraint from our perspective. It's just we're applying it and checking if it works. We've just been calling them constraints, however they are used.
Right.
Yeah, I can never remember which one it is, but like basically, logically, it's similar to contravariant and covariant, right? One basically one allows widening and one allows narrowing, right? So it's a.
Yeah, but from a C# perspective, it'll presumably look more like a constraint than like a variance.
Yes.
Where it'll be a where clause instead of a just a keyword applied next to the type.
Yeah, but the difference being that you would use it with potentially something like allows ref struct to indicate
Yeah.
that I accept all T, but in addition to the default things that T allows, I now allow something additional. So it's not a constraint, it's an anti-constraint.
Sure, I'm just like, if the two things you get are basically attributes and constraints, then it's a constraint. It's a anti-constraint, but an anti-constraint is a kind of constraint. So again, it just comes down to whether people would expect to see this new bit here or not, and if the answer is nobody calls it, then on the one hand, we don't care and don't need to obsolete it. On the other hand, we don't care and may as well obsolete it. We should never have defined the mask here because our rules say don't do that.
Yeah, I would almost say like let's approve the thing without the obsolete. We can, as we roll the feature out, maybe we find cases where people do the wrong thing, and maybe the obsolete one would have added value, and then we can review what the message should be, kind of like what we want people to do instead.
Okay. And then these attributes are. This is applied to a specific T, right?
Yes.
So this isn't that the method accepts by ref like, it's that this T.
Yes,
Yeah.
it's
Okay.
it's an attribute of the parameter.
Correct.
I'm just making sure that the name makes sense in the context that it would appear. So since we're on
it's
a
accept
generic type
now.
parameter, then it makes sense.
The terminology, as everybody's been using it, has been more allow. I can change it to allow by ref like. That way it'll match more or less what the C# is going to do. I put accept because that's just what I wrote 2 years ago.
I think by ref like is pretty much uncontroversial, right? So it's really just about the accept versus allow versus something else, right?
Which also a lot bleeds into the runtime feature as well. Whatever we decide, if it's accept or allow.
All right, so accept becomes allow.
I mean, seems reasonable.
Or permit, or Steve, do you know what LDM is favoring for what the
Right.
C#
Right
words
now,
say?
the working version is what Tanner said. It's where T colon allows or allow ref struct, but that's not in any way definite. It's still a work in progress.
So according to Merriam-Webster, there is this word called unconstrained as an antonym for constraint, but
So you want unconstrained ref like?
well, I would do this if we would do it. I would do it as a suffix like the other ones because the other ones are all suffixes. But it seems a bit weird to have by ref like unconstrained. But
Yeah, because
I think
it's not unconstrained. It's an anti-constraint in that it allows, and theoretically we could have additional anti-constraints in the future. In which case, you could say this allows bi-ref-like types, but it doesn't expand it to also include, like, I don't know, variadic generic types or something like that, pointer types.
I mean, if we wanted to, we can also use the term anti-constrained, right? But like, it seems way more verbose than just allow, which seems more. But it's also an API that is used by 12 people in the world, so we might be overthinking that.
Yep.
I think allow by ref like is fine.
Okay. And then we're good with the runtime feature flag name. Like, I have no issue with it. I'm just making sure that people actually looked at it.
What's it called again? Runtime feature.
I guess let's see what our normal naming rules are on that.
I mean, sure, that works.
Maybe we could just call it ByRef generics to
Yeah,
make it match ByRef fields.
I was thinking, or ByRef generic constraints, but ByRef generics is fine.
Yeah, ByRef generic seems fine to me too. I actually like prefix, yeah.
Yeah, I was gonna say, or generics except ByRef like is also fine, but all right, ByRef generics.
I mean, ByRef like, right? But yeah, was because ByRef is actually different from ByRef like, right?
But I think ByRef fields is ByRef like fields.
Fair enough. Then yeah, ByRef generics works.
But ByRef fields, you don't. It doesn't have to be a by. Oh, I guess
It means basically span and also
can have ref fields, but that's the ref field is incidental where it exists. The ref field is the idea. Just because it can only be on a ByRef like thing, like I can have a ref object field.
Right.
So it's
Yeah,
not-
because like you could already the field the concept isn't ByRef like fields because you
Right.
could already have a ref struct that was a field in another ref struct. It's specifically around any type can have a ref t field that's not span, and whereas this one is specifically about we're allowing ByRef like generics, and in the future we may also have ref generics, like you might have a ref t or a t star,
Right. Then
where
ByRef like generic
reference
is.
types and pointers are allowed in them.
Yeah, I think ByRef like generics makes sense. That seems reasonable to me.
Yeah.
All right, so we like ByRef like generics.
Yeah.
Okay.
So you said the runtime already has support for it?
Yeah, I added very basic support when I was going through it to get it a little bit cleaner. And of course, LR and native AOT. Mono does not. That's going to have to be next. But when I was going through it to put up these things, I found a few issues with DIMs and a few other scenarios that I needed to fix.
I see. So an existing version definitely does not have support for it, right?
It's not. It's only something for Roslyn to experiment. It's sufficient for them. Like they could do it with types, but there are some method issues that they.
Yeah, because currently the way we propose it here would be just, there's the runtime feature for .NET 9 only, so if you compile from older runtime, you don't have it.
Yeah, there's
Okay.
.NET 8 does.
That makes sense. For a moment, I was like, oh god, now we have to think about how we retroactively represent the fact that it already exists.
Yeah, I think that's a case where even if it did exist, it's this experimental feature, and you don't need to think about it. Kind of like when generic math was added, so you can just say it's only on .NET 8 Plus.
But are we proposing
Or
to ship it as an
.NET 9
experimental
Plus.
feature in .NET 9, or are we saying it's going to be stable?
So when we first started having this conversation originally a couple years ago, it was going to be the preview feature thing, and that's what I mentioned on the tag with it. But I don't know if that's still the case. I think the Roslyn team is committed to this. I'm assuming that's right.
Yeah, I mean, we can still add the preview flag later. It just means we have to think about how that's going to work.
But I mean, in metadata here, I don't know that we would put experimental or anything on this bit. Like the bit, if it's there, we're
No,
telling you
the
what it
way we
means.
would do it is we would put the app requires preview features on the runtime features thing, and then we would have to update our existing analyzer to check for this usage of this feature.
Oh, so the notion that if you use it in
If you
.NET
use
9,
it and the runtime you're targeting has marked it as required previous features on runtime features, you get an error.
So from the runtime perspective, there's no concerns with this. This was purely from where we weren't sure how Roslyn and C# was going to express it. Right. So maybe it's actually more, and this is a Jared question, maybe at the time it was more of a language preview rather than a runtime feature preview.
I see.
So this will be supported. There's no concerns about this from our side. We will have what is needed to make it safe.
Yeah, I would think that the runtime work is harder than the language work, right? The language work might be harder as in, oh my God, we have to find the syntax for that, and 12 people can't agree what that is, but that's different.
Well, there's also rules about there's some analysis on constraining what can go on inside of functions and that kind of thing. It's not a terrible amount of work from the runtime side, to be honest. It's just permitting things in places. And as a lot of these kind of features have over the years, we're really relying on the compiler to. We're stopping a lot of corruption, but there are places where people can get into trouble if they do it in IL. They go out of their way. So.
All right. Shall I move on?
Sounds good.
Thank you all.
Thank you, Aaron.
Enjoy.
All right, revisiting.
Anyway, so don't eat them all.
Cannot set read mode after creating a named pipe client stream instance.
Yes.
Eric.
Yes. So a lot of the back when pipes were added to .NET Core, there was and even when IO was first created, there was this goal to try and separate the Windows concepts from the API. And so a lot of those Windows concepts got put into the access control assemblies, and the API was changed. There was one exception, which I think was a miss, which was pipe access rights. Pipe access rights, while they are still very Windows specific, they're not really tied to access control at all. They're more akin to the file access rights, so like read only, read write, etc. They describe the permissions of the handle that you want to open to the pipe. There happens to be a use case where the Windows APIs have no way of opening a handle with read mode set. So what you have to do is you have to open the handle and then change the read mode afterwards. And we have API that exposed read mode on the client stream, but there was no way that using just public API that you could actually change that property, because we didn't include the constructor that allowed you to specify the permissions necessary to enable changing the mode. So the default handle we created would never permit changing read mode. So the workaround is, well, you can go pinvoke to create file yourself, or I forget if it's create file or if there's a special pipe opening invoke to get the handle, and then you pass the handle in. So this is just saying, hey, like, don't make people do that. Add back the API that we had before, and then move this enum down so that we can add it back. So we don't have this API at all today. We didn't create a factory method for it. It was a complete miss. So this is add it back, but put it as a constructor now, since we can push this enum down without pushing down the entire ACLs concept. I think last week folks had suggested that, hey, we could push down all of ACLs now and bring back all those things that we factored into separate factory methods. And yes, that is possible and plausible now, but I think that that's kind of a separate cleanup issue, because that's just about bringing back the access control concepts, whereas this is not bringing, like, this is something we don't have at all right now. So pushing this type down and exposing the constructor will unblock something that someone can't do at all with our public API.
Yeah, so one of the points that I brought up when we were talking about it before, we'll ignore all the ones that assumed that this was the same as the thing that had factory methods, is if the whatever flag is missing by default, right attributes, I think.
Yeah.
If the Linux, assuming that that named pipe client stream works on Linux, if it can already change the read mode because it doesn't have an analogous write attributes permission that's missing, then my suggestion was run it through Barry and Levi to see if we can just add write attributes to our default constructor.
We can't do that. That'd be a breaking change, and it would block the scenario where the handle was created without permitting write attributes. So that's possible, and so we wouldn't want to change the default here. That would be breaking, and it would also eliminate it would eliminate the scenario where someone was trying to restrict that access right.
Fair enough, but the point being, if we are already behaving differently on Windows and Linux, ideally we would not. But
I think these concepts don't project well to Linux at all. We will keep the same semantics for Linux. We could look more closely and see if, perhaps there's today this entire flags attribute, because it's in that access control assembly, it's treated as like not supported on Linux.
Right.
So and I have to check what the behavior for that read mode is on Linux. That might just throw as well.
And if it does, that's fine. But if it works on Linux, then adding this constructor saying it only works on Windows means somebody who wants to make a client stream where they can set read mode has to do, if Windows, go call this version, else go call the version that doesn't say it's going to throw on Linux. And then that would mean that maybe we need some other pattern that somebody can write platform neutral code to do what they want. But if it just throws on Linux, then I don't care.
Yeah, it's a no-op actually. Yeah, it does nothing on Linux actually.
I don't know how I feel about that.
It'll throw if you try and set it to something that's not legit, and it will throw if you try and set it to message. Yeah, it says message is not supported. So it's kind of plumbed through in that manner. Yeah, it throws not supported exception. I'll double check this, and if there's any problem here, I'll report back.
Okay, so basically the scenario of changing the read mode is itself only sensible on Windows.
It would seem so, yes.
Okay.
But yeah, I'll do a deeper dive when we go through and implement this, and if there's any concerns with the consistency, we'll raise that back. But yeah, I believe that it's just not relevant on Linux. I'm double checking. Yeah, we don't override it, and it's thrown in the base.
All right, and so this is about adding pipe access rights into the constructor, and according to APIs of .NET, framework only has one such constructor, which looks like the signature has been correctly preserved from framework.
Yes.
maybe modulo nullability, which
Yeah. We'll
do
give it
whatever
that
the right
treatment.
answer is.
Yep. We'll give it the right treatment in PR.
Okay, so I think last time, yeah, because here where it starts with like server stream, and I think somewhere we very quickly
Yeah.
latched on to, oh, there's this create method that already does it, and
Yeah.
so
Yeah. I had a typo in the top code, in the top API proposal. The class name was wrong in the top API proposal.
fair enough.
So that, I think that's what led you astray. That was my mistake. And then for the alternatives, I was saying, well, we could go and create a factory method for this, but I don't think we should, because that's less compatible than just adding back the constructor. So we wouldn't have to push the type down if we created a factory method, but it's like, might as well just push the type down because it's a simple enum, and then add the exact method, the exact constructor back.
Are the pipe access rights? So presumably this is marked as Windows only because the pipe access rights are Windows only.
Yeah.
If the pipe access rights is marked as Windows only because of its assembly currently, do we want to mark that as Windows only, or do we want to say they're just numbers, we don't care?
Yeah, my take was that they were just numbers and that we wouldn't like it. I mean, we could put it on the enum, but I think all the APIs which accept that enum would be Windows only rather than the enum itself. I don't know. Do we have precedent?
Honestly, we probably have a precedent both ways. I'm probably more in favor of doing what you have here and not marking it as supported OS platform Windows, because it's stupid that if you were ever to see one as a property and you are like two-string it, that it's like, oh, this only works on Windows. It's like, no, two-string totally works anywhere.
Yeah, yeah.
So, all right, I'm good with the changes presented. Anybody have any other feedback? And we don't have to do anything special other than adding the type forward attributes when we move the things around in the refs, right?
Yeah. Luckily, this one is none of these things are in packages anymore, so it's all just the current framework, just forwarded down, and yeah, it'll apply for Net 8, Net 9 onward. Yeah, it's not a. I don't. I'm thinking like one thing we do if a type is serialized, we will add a type forwarded from, but this type should not be commonly serialized, so I don't think it meets the bar to add a type forwarded from attribute.
It's also only used for binary formatter, right? Does anybody else honor type forwarded from?
Data contract serializer does.
DCS does. I see.
But yeah, I don't think you should be serializing the access rights for a handle in your. Well, we'll get feedback if somebody is.
I was about to say. I like your optimism.
It's like the only time that's relevant is like still old payloads work with new because of the type forward, but new payloads wouldn't work with old unless we put that attribute on there. So like
that's true.
Yeah. So if someone starts serializing with .NET 9 and tries to read it in .NET 8 and used this flags, then maybe they'll have an issue. But yeah, let them tell us that if that's the case. This is a very mundane type forward.
And our response is going to be, "Oh, muffin."
Oh, we could like adding that attribute back is okay.
Yeah, we can do that. It
doesn't hurt anything. It's just cruft. It's metadata in our assemblies, so the assemblies are slightly larger. I guess the string that gets serialized to the payload, it might be slightly longer. Yeah, I don't know.
You're undoing all the perf gains that Stephen worked hard for.
Let's just put it in MS Core lib then or then you don't need to include the assembly name. All right.
All right.
Cool.
Thank you, Eric.
folks. Sorry I led you astray before. I will not do it again.
No,
Sorry,
it's fine.
we
Had a good conversation.
closed your issue because we fixated on the wrong point. All right. For what feels like the 800th time, add a first-class system threading lock type, 34812.
Yes. Hi. Can you look at the latest revision? This is hopefully just a small change.
I don't know what latest revision means.
So at the very top, it says Calville, and there's a little down arrow.
API proposal.
If you look at the history of the changes to this comment at the very top, and then look at the latest one at the top. Yeah, and scroll down, and that's basically the diff. Most of this is just cleaning up stuff that we already decided not to do last time. The main change here is renaming the enter lock scope method to enter scope. The reason we used enter lock scope before is because we were initially trying to create a general pattern-based approach that any type could use to integrate with the lock statement. In the last LDM meeting, we discussed that, and there seemed to be several issues with that, and it seems difficult to do that, especially to make it usable with existing types. So the decision was to special case the lock type for integrating it with the lock keyword. So with that, we don't need to add the redundant lock name anymore in the enter lock scope. It can just be the simpler enter scope. In the future, it was also discussed like we may want to have something like iLock pattern of T or T scope, where T scope is disposable, and then the enter lock scope method would return the T scope. But right now we're using a ref struct for the scope, and we can't use ref structs as a type parameter at the moment. But even if we were to do that, it still wouldn't allow existing types to use it because it would change the behavior when using objects of those types with the lock keyword. So if we want to do something in the future in a pattern, like using some kind of a pattern or interface, it may have to be something that allows existing types. I mean, it would be nice for it to be usable with existing types as well, in a non-breaking way, so there might be like syntax changes or something else. Also, we could explicitly implement that interface method and hide it. So I think enter scope is probably the more appropriate one.
Apologies, we talked about this last time, but what's the reason for making scope a ref struct?
There's a performance benefit because there's a thread local lookup to get the thread ID both on enter and exit if you just call those methods directly. With enter scope, we can store that thread ID on the enter and reuse it on the exit. So we avoid one thread local lookup, and it shows up like about anywhere from 0 to, if I remember correctly, 0 to 10% or 15% improved depending on what the lock is doing.
By making it a ref struct, you basically disallow sharing across threads easily because you can't stash it away, basically.
Yeah. So dispose would be guaranteed to be called on the same thread as enter lock scope or enter scope, except if it's copied, but then it would check for that and throw.
I mean, I don't know that we have any notion of a lock type that can move to a different thread. Monitors thread local.
Right. I think the only one right now is
You could use manual reset
Well,
event
there
and
are
give
a
it to
few
somebody else, but
Yeah, like spin lock is not thread. It doesn't have thread affinity, but lock does and monitor does.
So what do you mean by moving to a different thread? I mean, like, it's more like, you can't read the scope variable from a different thread, right? Because it's the type system makes that very difficult for you to do.
right. But the purpose of this type is to be a new target that you can put inside a lock keyword, and
Right.
so you're just going to say lock on underscore or s underscore lock, and that is going to turn into scope equal interscope try do whatever was in the lock finally scope
Right.
dot dispose. So you don't need to pass
Yeah.
the scope to a different thread. No one's ever going to see it. It's a hidden local.
Yeah, no, I mean, I get that. All I'm saying is, like, I didn't understand why we made it a restaurant like that. It seemed like it's just effectively scoping out the dispose call, right? But it's just the perf thing that Count mentioned. That makes sense.
So if it's not a restrict, it would be copyable, and then if the dispose is called from a different thread, we'd have to check the thread ID using doing a thread local lookup, and then throw an exception. Whereas with the ref struct, we don't have to check the thread ID at all.
I mean, somebody can pass it, but I guess they can't get it to a different thread.
Yeah, how would you do that? You would have to fundamentally stash it away somehow, right?
Yeah, because
Well,
you could pass it by value into a different method, but I don't. But in order to jump to a different thread, I think you'd have to promote it to the heap. So
Yeah,
so
you
this
basically have
prevents
to
that.
pass it as state to either something like task creation, which would require boxing, or you would
Yeah.
have to store it in a field in order to read it from the starting delegate, right? That's what I'm saying. I don't think it's impossible. If you try really hard, you might be able to do it, but the type system would make it really difficult for you to do by accident.
Yeah. So yeah, the changes seem fine. My recollection is we added the word lock, because it was the pattern, and
Right.
now that it's not a pattern, then we can get rid of lock.
So that's the thing that's not entirely clear to me. So what is the actual language requirement to use a type in the lock statement now? Because right now you can't use anything else, right?
What's any reference type, because that just calls monitor.enter on it, or
Oh, sorry, that's right. You
or
can
the
parse
special word,
any.
the
Yeah.
special type lock will be recognized
Is the
differently
compiler
Yep.
just binding to it by name, or is it
if
binding
you
by
have a new
shape?
enough.
There's a speclet for this. I'll put it in the chat. It's looking for the full name, System.Threading.Lock.
I see.
And
So
then
the type is
string.
specialized.
Yeah.
Yeah.
Yeah, I mean you will get if you lock against one of these from an older compiler, it will call monitor.enter instead of lock.enter scope, but don't use old compilers with new framework versions.
Yeah. I mean, there goes. I mean, you can easily see people doing this by accident because at some point they pin the language version, then they upgrade the TFM later, right? So that's a thing I've seen. But you know, there's not much you can do. I mean, it depends on how they do it. If it's not tied to language version, then maybe it doesn't matter. If it's just literally you have to use an old compiler, then you would really have to fight the tooling hard to do that.
Yeah, you'd have to do something like, I don't know, be the core XT build system.
Yeah, or call CSC literally by hand, right? Which, yeah, we don't care for those people.
All right, and then count. Why are we removing try enter?
We're removing the try-enter lock scope. We talked about that last time, and we decided not to do that. So I was just doing some extra cleanup as well while I was editing this.
Okay.
Is there any reason we need to try enter with milliseconds?
We have it with other other similar APIs. So
I mean, at some point we basically, like I think in V1 we only had the milliseconds one. Then at some point we added all the time span ones. So I was wondering if we have the time span one, why would we still have to have the milliseconds one?
it's a bit easier to use. The underlying APIs or the underlying subsystem also uses milliseconds, so we're going to convert it into milliseconds anyway. But if you pass in a time span, we'll have to check it for range and for exceptions and stuff. With milliseconds,
So
it's a
it's
simple check.
fair enough. Yep, seems reasonable. Is there any sort of compat issue around me changing my object fields to use the lock type?
You'd have to be careful about passing it around or casting it to object, but the speclet kind of covers the obvious cases. It will catch explicit and implicit casts to a different type and issue compiler warnings. But there are ways to cast it in weird ways into object, indirect ways. So checking for those kind of things. But I think the major issues would be caught, and the minor issues are kind of the oddball cases. Those are hard to catch.
Yeah, I mean, maybe, and I don't know if it's what Emo meant, but maybe a variation of that question is there any user observable difference between doing lock on object versus lock on lock? Like, will it potentially change the way starvation works and the order of sequencing and yeah, is there any user visibility change?
Not really from a functional perspective. Lock has some minor differences from monitor's lock, but they're just performance related stuff, not really functional differences.
I mean, the big one would be timing, right? I assume that this is cheaper, right? So if you have a race condition somewhere, you might get lucky today and then you're not getting lucky. Or you might get more lucky now than before, right?
I mean, fair enough, but you'd have the same problem with monitor if you just never ended up being, or never ended up with contention.
Yep.
So.
By the way, do you ever consider making monitor throw when you pass in lock? Presumably that's expensive.
Yeah, we considered that and measured it. It's kind of hard to measure the cost of that, but it definitely shows up on ARM at about like 3 to 5% regression in the very typical simple lock case. So that's not something we wanted to do.
Yeah, that makes sense.
X64 seems to be really good at prefetching through that, so it's kind of hard to measure on X64.
All right.
Yeah, I mean, if the compiler warnings are good enough, maybe that's good enough, right? But because that would be fucking impossible to debug, right? If you accidentally end up locking the wrong thing. But yeah.
Yeah, I mean, it feels like it'd be weird because if you saved the field as object, then now you're just doing monitor.enter. The only way that you'd get like half of your locks are calling lock.enter and the other half are calling monitor.enter is if in half of your lock statements you cast it to object. So you would have had to store it as a lock and then cast it to object.
Yep.
I'm just, why would you add a
No, I
cast
mean,
there?
I'm just saying,
It's
like,
never
yeah,
needed one before.
I would hope that it's hard to do. Like, if it's hard enough to do, I think it's fine, right? It's just that if you actually do it, then good luck debugging that.
Yep.
I think it should be fairly hard to cast an object of the lock type to object or to a different type. And like, well, for instance, one case may be like you have a type of T and you use lock for T, and then in that type you have a method that uses lock this or something like that. That will lock using monitor.
Yeah.
Is a toString, a semantic toString, expected to exist on the lock type? Like, is it going to provide any debugging information via toString?
Good question. Haven't thought about that.
Because if yes,
it...
then we need to make sure that we don't print the warning when you call string.format passing this in.
Right.
Or any of the other string concatenation things.
I don't think it's necessary right now. There's going to be other diagnostic information.
Okay, I mean that's the only time that this would get freely turned into object that I could think of is like string.format, and then it'd be like, oh, you shouldn't cast a lock into object, and you'd be like, get over yourself.
Yeah, like when firing an event currently, I need to update it, but it needs to be cast to object. So I'll just ignore the warning around.
Mm-hmm.
I mean, you could always call toString manually, right? But
true. And I think like string plus object, I think calls object toString instead of calling string.concat of object, because there may not even be a string.concat of object. But the string.format with params object would definitely introduce the cast.
Okay.
But okay, I mean that's really a compiler test case, but just thinking through it now while we're mentioning warnings. Alright, approved again.
Awesome, thank you, folks.
Thank you, Count. Do we have quorum to continue? I see we lost Steve at some point.
Yeah, I mean, it's a good question. Do we have it? I mean, we can probably do yours, would be my guess.
Maybe.
Last one.
It has some contentious naming, so we'll see if we can come up with happy names here. Alright, so add additional hash algorithms for X509 subject key identifier hash algorithm 9er7158. So the existing enum, you get a choice of SHA-1, SHA-1, or SHA-1. And
different versions of it.
Right. So I mean, these names were named a long time ago, long before I was on the team. Cappy SHA-1 is called this because it was a thing Cappy did that was different than what the spec said, but these two come out of the RFC as SHA-1 and a truncated SHA-1, which are over something. So there's the public key field has the outer envelope part, and then it has the inside part, and I think these two are over the inside part, and this is over the outside part, which has made it different. And then RFC 7093 came and added more added new algorithms, and then they changed. So these three are over the outer part, and these three are over the inner part. And then these are also truncated, and these are not, and so it was this very complicated. We're adding two ways of doing SHA-256, two ways of doing SHA-384, and two ways of doing SHA-512, and how do we tell people? So Kevin threw in the truncated here, but this truncated isn't just this truncated. It's actually a completely different behavior because it's hashing fewer bytes and then giving a truncated answer. And then the best compromise I came up with it is just say they're all from RFC 7093. If you care what it's doing, go read the spec. And then Kevin rightly points out that these names are ugly. So
What about, so how is truncated the same as short, or is short and truncated again completely different semantics?
Short and truncated are different because the spec says when you're doing the older spec, when you're doing the thing that we call short SHA-1, in addition to truncating, you replace the first byte with like 4, which says like, I'm giving you a short value. It's like, you'd think that the fact that it's short would have been enough to say I'm giving you a short value, but yeah.
I see.
So we could say we don't care, and
they're all mutually exclusive, right? You can only do one of them.
So these are only used when you call the constructor that takes the public key object, and then what would you like to do? Like, what would you like us to do to turn it into a series of bytes to be your identifier? You can build the thing however you want and pass in bytes yourself. These are just the 7 RFC recommended ways of doing something. I guess 8 RFC recommended ways of doing something, plus the one that Windows invented. So we have 9 ways that we'll do it on your behalf, or you can just pass in your own bytes.
I mean, my personal opinion is I'm fine with the names as you propose them here. I mean, I agree with you that they are not pretty, but it's also one of those things where, well, you give people enough thing to hopefully know. Like, I would assume if people know what they want, they can select between those names. Like, I'm certainly not one of those people, but I'm also not the target audience. And that's something that only you would know the answer to. I would assume RFC 7093 is something that they know of. I'm not sure they can choose between truncated and the other version, but hopefully that's, again, contextually clear to them. And as long as that's the case, I think I'm fine with the proposed names.
Fair enough. I mean, I think the primary alternative would be just kill all the prefixes and in documentation say that this is doing the thing that RFC 7093 says, which is blah 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 blah.
Right.
And then the
Which
only
is also
reason
fine. I mean,
to do that, we would add the prefix defensively if there were 2 different RFCs that gave 2 different opinions, but
right.
But I don't know that there's going to be a super conflicting opinion other than where RFC 7093 also gave us this one. Right, so all of these are 2 conflicting opinions from the same spec. But
so are the other ones also RFC 7093?
These 2 are RFC 3280.
So they're different RFC. It's just we didn't name it.
Right, because these were just like the only options.
Right.
This whole notion of subject key identifier came from RFC 3280. So.
And then they had a new RFC to incorporate 256, 384, and 512.
Right. And then they, instead of just saying that thing we said before but with a different algorithm, let's change how we're doing it in the meantime.
If that's true, then I think I'd be in favor of dropping the RFC prefix. And then the next question is, does it make a difference to say short versus truncated? It's like, yeah, well, the encoding is different, but, well, it's different because it's SHA-1 versus SHA-256, so maybe you get away with that as well. In which case, the naming looks like what it's right now. But that's also up to you.
Yeah, I'm probably okay with saying short instead of truncated, just or being consistent with what we have, but they are they are different, but probably not in a way that we really need to manifest in the API. There is.
And then do we control the enums, the enum values, or is that also dictated by someone else?
They're us.
Then I would probably reverse the order to the non-short ones first, just to match the existing pattern as well. And then whether or not you interleave them, again, is up to you.
Yeah. So, for what it's worth, this is what we call short SHA-1. The byte 4 followed by 60 bits of the thing. And then the ones from the newer RFC don't do this nonsense of adding a prefix. They're just like, yeah, compute the hash and then chop it. So
I mean, it seems fine. I mean, you can just say that's the difference because you also chose a different hashing algorithm.
Yep.
I mean, that seems. I think the important information here is we clip it, right? Truncate it, shorten it, whatever you want to call this.
Yep. Hey, look, at one point I proposed the thing that you just said, Emo. Except you want to flip 3, 4, 5, and 6, 7, 8.
Yeah, pretty much. I mean, like, it just, I don't know, if you go with short, it just seems reasonable to do the other ones first. Just because that's what we have done before, but
Alright. Happy?
I mean, looks reasonable to me.
Yeah.
My extensive cryptography knowledge always comes in handy.
Yeah, I mean, I'm amused that I got to just copy one of the middle versions of the proposal, so.
Jenna, do you have an easy one?
Yeah, there's a couple. There's one related to span that's simple, and then there's some intrinsic ones which are pretty simple.
Yeah.
The span one is 96952. So, given read-only span, we already have allowances for covariance. We know it's safe because it's read-only and therefore immutable. Runtime already makes assumptions around this. We remove type checks as compared to what span does, and so there's just generally a proposal for allowing a type-safe method which does cast up, which allows you going from the T to the T derived. This already got some looking at from Stephen and Levi, and it's just a generally desirable API for doing this safely. And of course, we already have this API in a mutable array, so it's really just bringing it down into the core type everyone uses for dealing with memory.
Do we need the inverse one on memory marshal or no?
I don't think so. Most of the time when you're dealing with memory, you explicitly want to extract a span anyways, because you have to do that for indexing and things. So generally it's better to just get the span and then do cast up.
That seems reasonable to me.
Yeah. The only real question here was, should this be an instance method on span itself, or should we make it an extension method on memory extensions with the other, with most of the other extensions?
Because if it's on memory extensions, you'll have to specify both T's.
Well, no, because it's an extension method, right? Oh yeah, you're right. It doesn't work at all, even with the extension, because the compiler's not that smart today.
Yeah. Also, oh yeah, because you have the return. Yeah, because you'd need to tell it what the return type is. All right. Wait. Which way is this casting?
It's a static method, so you
Yes.
have to specify both either way.
All right. So up here means toward object. Okay.
Yeah. The same way we did it on immutable array.
Yes, but I don't know that. I don't know that up and down is a good notion here, but I do agree that we have that cast up exists despite APIs of .NET not
I
showing
mean,
it
it
in
is
the
pretty
search.
well known though. I mean, up and down are pretty standard terms.
I always get them personally confused because I think of it as base type, and the base type is lower because it's the base, and so I always think down means towards base, but that's not what it means.
Yeah, I always think of it as a tree, but the way we draw a tree usually is the root is at the top, so object is at the top, and so that's the direction you're taking. But
Exactly, but it's we call it the base class, but then we also call it and we call it higher level types, meaning they should be drawn on the higher level. But then when you make the type tree, you invert it.
And then if you're not a programmer, trees grow out of the ground, so the roots are also on the bottom.
We should not be in charge of anything. That's because our stack also grows from the top. So, like, what can I say, right? So,
Yeah.
but yeah, I mean, I would say the prior art is to me what convinces me to do it the way it's proposed here.
Yeah.
I mean, the usability is decent because even if you don't know what it means, I mean, you see it, right? You say read-only span of object cast up, right? And it's like, well, that's what you're getting. So you basically specify the type you want to get to. So
right.
Yeah.
Yeah. So as on memory extensions, yeah, you'd have to specify. You'd need to specify tret, and you can't. The C# language doesn't allow partial specification. So
Right.
this form we'd have to do. You'd have to call some span dot cast up.
Yeah, object comma string, right?
Yeah, object comma. I don't know, dictionary of thingies, and on this way you only have to specify the return type. No.
Yeah.
On this one you don't.
Yes. You specify the return type.
No, because you'd call read only span of object dot cast up.
Yes. And what you get back is the read-only span of.
Right. Yeah. So you wouldn't do generic invocation on the method. You do generic invocation on the type, which is the return type.
Which makes sense, right?
Yeah.
Because you can only infer the thing you have, right? So like, and the thing you want. I mean, we don't know what you want, right? So you have to say what you want.
Indeed. Well, because thinking of it in the syntax there, and I mean we can say cast up is. We have prior art, but since you'd have to call it as read-only span of object dot cast, to me the next word should be from, and then it's just like whatever this is the right answer.
Yeah, I mean, I would just say the existing method that we have is that, so we'll just stick to that one.
Fair enough.
Yeah. Well, and I think we wouldn't want cast from because it's a one-directional cast. You can only cast to a more base type. You can't cast from object to string, for example.
Yeah,
it's only
but
from string to
the generic
object.
constraints are going to stop you there. So
Yeah.
Yeah.
But yeah, prior art and matches name, matches signature, etc. So
I'm just looking to see if I can find a cast from, because I think there's only the one cast up, and there's no cast froms. So of course.
I mean, the question is whether the compiler can do that automatically moving forward, because it seems that the compiler wants to special case spans anyway. So maybe that's one thing.
This is actually the API it wants to be able to use to do that.
Oh, fair enough. Yeah. I mean, in that case, like, who cares, right? It's just the compiler invokes it. So.
Mm-hmm. Yeah. So, by the way, Emo, something's going wrong with search, because
Can't be.
cast up isn't being found, but it's right there. So it's in your index, but not in, or it's in your table, but not in your search.
In non-public APIs, we use cast from.
Meaning the developers think they're a better name.
Right? Yeah, I agree. There's something wrong. Anyway, but yeah, so, and approve, I guess.
Yeah, so I think we want to put it on as the static on read-only span, because
Right.
it'll make the syntax better. And then, yeah. I think T derived is what we called it. Yeah. Do we need anything weird with nullability annotations here?
I don't believe so. We don't appear to have it on a mutable array.
Well, a mutable array, Nemo thinks it's painted as not null.
We should match mutable array. Whatever it's doing. Let me see the actual source here. Oh, it's because it's where T derived :class question mark. So the question mark is on class.
Meaning,
Really? You can say class question mark?
Mm-hmm.
Holy shit.
which I guess means a reference type or a nullable reference type.
I think it just means another reference type, right?
Yeah.
Nullable is hard.
Yes. But right, so this nullability becomes this nullability, and then this nullability becomes this nullability. So I think the answer is put the question marks where you want them. And then maybe something in nullability flow will yell at you of if this has a question mark and this doesn't, of like, hey, where did null go? But I don't care.
Isn't the rule if you don't specify anything, then the nullability is the same you put in?
Right, so if this is a read-only span of array list question mark, that's how long it took me to come up with a type that wasn't generic, then this becomes a question mark and this becomes a question mark from the generic inference. And then what I don't know is if you said read-only span of object instead of object question mark, if the compiler is going to yell at you of you've obviously violated some sort of generic or some sort of nullable sanity. Or
I don't think the compiler could, right? Because as far as the compiler is concerned, there are two independent type parameters, right? You have T and T derived.
Yeah.
How does the compiler know that there's a relationship between them, right?
Well, it knows T derived has to extend T, which might mean that the nullability extends there as well, but I don't know if that's true. It could. You could be telling it like, oh, and clearly the nulls go away, which is again the problem with nullable reference types of they're not true, they're suggestions. So if a question mark goes in, make sure you write the question mark coming out.
Gotcha.
Okay. Anything else we can do with 3 people?
98055. So, as has been discussed in the past, we have the vector types, and when dealing with vector types, there's frequently mask operations you end up doing, and those are used to effectively emulate branching. How masks work vary based on hardware, so ARM does it very differently from classic x64, and even depending on what instruction sets are available. So AVX512 adds dedicated masking support to the hardware. You no longer emulate it bitwise. Similarly, ARM SVE has a similar concept. They've got this dedicated masking register. And then additionally, when dealing with a variable size type like system numerics vector, it's very hard to build masks statically. And so while vector 64 through vector 512 expose this API called extract most significant bits, which can be used, that's not always the most efficient way to do it on ARM. And then you can't have an equivalent on vector because you might have more than 64 bits on your system numerics vector. So the proposal is we expose 4 APIs on each type, which covers the most core concepts you need to do with these masks and comparisons, which is in particular, you want to know for a comparison, were any results true? So did any matches exist? You want to know how many matches existed in the comparison, and you want to get the index of the first or last match. Those are the 4 operations we do, in which we have internal helpers for today, using essentially these names to allow efficient handling of that, regardless of the underlying hardware.
And what are these? These are comparing off of a special mask register?
So they take in a vector or a vector 64, and a match is considered on a per element basis either all bits true or 0. So 0 means false, all bits true means, or all bit set means true. That's how you do bitwise conditions for branch-wise, or for branchless code.
So if you pass in a vector of int and they're all 1, what does any matches return?
Any matches, if they're all the value 1, it returns false because none of them are all bits set. And if you were to do compare equal, you get all bits set returned.
And then get match count on vector event returns the number of values in this vector that are -1. Which is all bit set.
That are all bit set.
Yeah. Right. I assume for vector of int, all bit set is -1.
Yes. Yeah. And then for uint, it's max value.
And so index of first match is again index of first all bit set.
Correct. On x64 based hardware before AVX512, what it does is effectively trailing 0 count of extract most significant bits.
Yeah, I think we need more people for the names on these.
Okay.
Because any matches and get match count and index of first match and index of last match, like, that's not using match in any normal .NET sense of the word. That's, hey, we did a thing previously, and does this map to the state the vector would be in if this thing was true? But if we describe the method functionally, that's the any matches has any all bit set values.
Yeah, so any all bit set.
Yeah. And I mean, if we replace matches with all bit set, then I'm okay with the functional names, but then it's probably that the people who want to call them won't know to find them. And so I think we need more people to argue about these names.
Okay.
All right. Yeah. I don't know that there are going to be any more slam dunks.
There's the bfloat 16. There's the bfloat 16 one, which is just expose bfloat 16. It follows the same signature as the other floating point types. It's needed for ML scenarios, and it is a ABI primitive on platforms now.
Do we have the prefix B on floats already?
Bfloat is the official name of the type. It's the name that languages are adding for the keyword. Literally bfloat 16.
And double is called float 64, right?
Yeah.
Okay.
We expose that as, system dot double, but arguably that should have been called float 64
Oh,
when we
so we
shipped it
don't call
originally.
it float 64. Okay.
Yeah,
I
and
was trying to
single
think
is
what's the
single,
real
half
name.
is half.
Yeah.
Yeah, the real name is single, half, and double, and arguably they should have been float 16, 32, and 64, but we missed that 20 years ago.
Indeed. Yeah. How do you feel about B float, Emo?
I mean, that all seems reasonable. I mean, they all have weird names because fundamentally we get more and more specialized. So
Well,
I don't know. It's hard. I mean, like fundamentally, like none of these types will have the same usability as other built-in types, right? And that's just the nature of the beast. So the question is, are the people who are the consumers of those types able to get the right usability, and are they able to pick those type names, right? And I think that's similar to the SHA-1 argument earlier. Like that's kind of where I defer more to Tanner. It's like, what does naming wise make sense? And then, okay, given those, I guess, considerations, I mean, what's the most natural projection into .NET, right?
right. Well,
Like,
it's sort of, even if
it seems
the
reasonable.
language wanted to call the keyword bfloat 16, like system int 64, we didn't call system long, and so it's, do we feel that the B here would need to be expanded for our type name rules? But
The
if nobody
the
knows what the
B
B stands for,
the B technically stands for brain, BRAIN. No one knows what it means.
okay, so B stands for B.
So, I mean, kind of like, yeah, this is similar to like when you talk about a B tree, right? Everybody knows what a B tree is. Nobody knows what the B stands for. But I think that, to me, almost like, if there is a language keyword, that's almost an orthogonal decision. I mean, most of our numeric types have names that we would normally not use for type names, right? They're all abbreviated usually.
Well, that's why I
You
was saying
you
I
could
don't.
argue that int64 should have been integer 64, but we didn't name it that way, right? So,
Sure. I'm just saying that I didn't quite care what languages we're using as the keyword for the type. But
I mean, I would assume we never use keywords for numeric types ever again, right?
It's the language. So even for things like half, it's the language has decided they may add language support in the future if there's enough demand for it. So the language in the future might add, a float 16 or a B float 16 or a half keyword if there's enough demand for it. But as of right now, there's not the demand for the language to add dedicated support, but there is the demand for the libraries to expose the baseline support. And
and
All
then
right.
the
16
one
here is this
thing-
is 16-bit memory.
yes,
Yeah.
yes, and there is theoretically room for a B float 32 in the future, or it's a well-defined format and standard, but the only thing that exists today is B float 16 because that's what's used for machine learning.
Right. But just making sure that this wasn't. It's called bfloat 16 because it has 16 bits of mantissa. It's called bfloat 16 because it's a 16-bit floating point value using a different format than IEEE 754.
Right.
Okay.
Notably, the difference here is that, so doing a proper conversion between half and single is potentially expensive, especially when there's no hardware support. So what bfloat 16 is it's literally a single, so a float 32, where you chop off the lower 16 bits. So it changes it to it keeps an 8-bit exponent, and it changes from a 23-bit mantissa to a 7-bit mantissa. And they do that because that makes it incredibly cheap to convert, and they don't need the extra 16 bits of precision when they're storing the info. I think the one thing to note about the API surface here is that what's here in the proposal is the minimum surface area needed. It's kind of like what we shipped for half in .NET 5. There is a general desire to add an additional comma there and put floating point IEEE 754 so that it participates in generic math. But there was not the desire to list the entire set of APIs that generic math requires in the proposal.
But it's not an floating point IEEE 754. Or rather, it's not a IEEE 754 floating point.
Yesn't.
Yeah. And then I assume on because you didn't actually define any of the number interfaces here.
Right. The desire is to have them. I
just assumed it was having that it had like floating point, but not IEEE 754, because that one's talking about that includes storage semantics, I thought.
No, it doesn't. It doesn't include any stored semantics. It just basically indicates I follow the rules of IEEE 754, and I expose all of the IEEE 754 required operations. And so, from that perspective, bfloat 16 does indeed follow the spec. The only difference is that you basically, the way you do the operation is you upcast a single, you do the operation, and then you truncate off the lower bit. So there's basically an explicit round operation after each one. So it still follows all the semantics required and everything else.
I mean, presumably that's not true for whatever bit increment and bit decrement do.
That's still accurate for them. You would just bit increment on the 7th bit instead of the 23rd.
Right, but I was just saying it's not the same as take it, convert it to single, call bit increment, then down convert it, and
yeah, there's a couple where it does technically differ slightly.
And you'll note that here I actually apparently used down in the wrong direction. So. Yeah. Yeah, seems fine, and I think whatever generic math levels we want to stick it in at are fine. So where in the floating point types universe do we get the go export yourself?
So for binary integer, we have the read and write explicitly as a 2's complement number. So regardless of underlying storage format, it gets stored or loaded as a 2's complement number, typically shortest 2's complement. For floating point, we have to break that apart into get the exponent as a 2's complement number and get the mantissa, I think we publicly call it significant though, as a 2's complement number. And so the way to reconstruct the value is via radix to the power of exponent times mantissa,
right?
Which is the standard.
I just want to know what interface that's on.
Yeah, I think that's on floating point. Because all floating points should be able to represent themselves as, it's on floating point, because everyone should be able to represent themselves as a radix, exponent, and significant regardless of the underlying format.
Okay, and that's where? Because I don't see like get radix or get exponent.
So there's get exponent. I'm looking at it on source.net right now, and it's instance methods, get exponent and stuff. I think Gimmo's tool's broken.
Don't say that.
and radix is on iNumber base, I believe, because all numbers should have because all numbers have a radix.
Yeah, somehow you're missing members, Emo.
I do what?
Unless we recently added these.
So I am not indexing .NET 9 bits yet. So
Right,
that's the
that's why
thing I
I'm
need.
asking Tanner. When did
Yeah.
we add these in
Dot,
9, or have these been here for a while?
.NET 6/7.
You're looking at the wrong type, though. Pretty confident. You're looking at the system type. Is that not in numerics? Because
Oh,
this is
the
also like,
system.
We have two
Yeah,
I
you need to
floating
look at
points.
system new.
yeah, that's an old
So
package.
in
System runtime experimental, I should probably exclude at this point.
Yeah, that was the experimental version that we shipped in .NET 6 before we decided all of these should be hidden away in numerics instead.
Fair enough. Okay. And so I see that. Yeah. So here's at least where the byte count is. Oh, because it's red exponent, not get exponent. Okay. And then the IEEE 754 presumably extends this. But all right.
Right.
Okay. Yeah. So back to if it conforms to all the IEEE 754 semantics, then I think this is an easy API approved of whatever level of number you want to be.
Yeah.
As long as the fact that this does not store compatible with an IEEE 754 is not a reason to not mark it as IEEE 754.
Right. And we don't actually give a way to basically do binary serialization of the raw format.
Oh, it's floating point IEEE 754, I think.
Yeah. We wanted
we
the
made
same
those
prefix
little.
and then. Yep. Following correct naming conventions or casing conventions.
Chat asks about ISPAN formatable and ISPAN parsable.
Those are part of the generic math interfaces. All I numbers are ISPAN formatable, ISPAN parsable, and UTF-8 span formatable and parsable. Because any number type should be trivially able to be displayed and parsed from user input.
Okay. And then, are there non-cast operators of these?
I
guess if you go generic math, you'll have the
iNumber.
Yeah, you'll have the create,
truncating, saturating, yeah. And of course, all explicit. We also do explicit cast up to float and double, even though technically those are lossless, for the same reasons we did on half, which is that this is a net new type where you're converting between a built-in primitive and a non-built-in primitive, and that can break overload resolution in subtle ways, so we don't want implicit casts there necessarily.
Okay. And on half, we didn't add methods like to single and to double.
Right, because we don't have those for any of the primitive types either.
Okay. No, yep. The good old GitHub bug. All right.
It's exactly new.
That was a productive day.
Yeah. Bee float. Oi. So, yeah. Do we have a Thursday meeting? I don't remember seeing one.
I know we still have more SVE. I don't remember if we scheduled a Thursday meeting or not.
We did not so far. So like, I think that was my question for you. Like, so all the other remaining ARM work are we inviting them again? Presumably the answer is yes.
Yeah, we generally want to invite them.
And it's all
Um,
ARM work, right? Yeah, they're all ARM 64. So then how about I set up
yeah,
another one for,
there's.
sorry, what?
Uh, I was just gonna say there's going to be some Intel proposals coming up too, for AVX10. Um, but those will be much smaller, and they're not really new concepts because AVX10 is just they're converging their ISAs. So
And all the ones that are marked untriaged up by accident, presumably, they should all be.
they're marked. So Kunal went and marked all of the pending ARM proposals as ready for review. The untriaged ones are ones that I'm still going through and double checking that there's no feedback that I have to apply of like this isn't quite right compared to advanced SIMD and stuff. And I'm
Gotcha.
getting through those before each review, so we've got enough to get through.
So I should ignore the untriaged ones for now. And then how about we set up a meeting for Thursday, invite them, and then just pick the next three ones that are not marked untriaged?
Yeah, that works. And I'll probably
Good.
get a couple more marked properly triaged by then too.
Sweet.
All right.
Then
So, yeah, for the home audience, anybody who wants to be here for another round of intrinsics, you can join us on Thursday at 10 a.m. Redmond time. And if that's not your cup of tea, you can join us for not intrinsics next Tuesday at 10 a.m. Redmond time. So, thanks for good feedback today and for being here with us, even with our short attendance. And we'll see you at some future date on our same .NET time on our same .NET channel. Ciao.